While we're experimenting with a recipe, we need to keep tasting it constantly to make sure it meets our expectations. This is the model evaluation portion of the model training stage. Vertex AI provides extensive evaluation metrics to help determine a model's performance. Among the metrics are two sets of measurements. The first is based on the confusion matrix, for example, recall and precision. The second is based on feature importance, which we'll explore later in this section of the course. A confusion matrix is a specific performance measurement for machine learning classification problems. It's a table with combinations of predicted and actual values. To keep things simple, we can assume the output includes only two classes. Let's explore an example of a confusion matrix. The first is a true positive combination, which can be interpreted as the model predicted positive, and that's true. The model predicted that this is an image of a cat, and it actually is. The opposite of that is a true negative combination, which can be interpreted as the model predicted negative, and that's true. The model predicted that a dog is not a cat, and it actually isn't. And then there is a false positive combination, otherwise known as a type 1 error, which can be interpreted as the model predicted positive, and that's false. The model predicted that a dog is a cat, but it actually isn't. Finally, there is the false negative combination, otherwise known as a type 2 error, which can be interpreted as the model predicted negative, and that's false. The model predicted that a cat is not a cat, but it actually is. A confusion matrix is the foundation for many other metrics used to evaluate the performance of a machine learning model. Let's take a look at the two popular metrics, recall and precision, that you'll encounter in the lab. Recall refers to all the positive cases and looks at how many were predicted correctly. This means that recall is equal to the true positives divided by the sum of the true positives and false negatives. Precision refers to all the cases predicted as positive and how many are actually positive. This means that precision is equal to the true positives divided by the sum of the true positives and false positives. Imagine you're fishing with a net. Using a wide net, you caught both fish and rocks. 80 fish out of 100 total fish in the lake plus 80 rocks. The recall in this case is 80%, which is calculated by the number of fish caught, 80, divided by the total number of fish in the lake, 100. The precision is 50%, which is calculated by taking the number of fish caught, 80, and dividing it by the number of fish and rocks collected, 160. Let's say you wanted to improve the precision, so you switched to a smaller net. This time you caught 20 fish and 0 rocks. The recall becomes 20%, 20 out of 100 fish collected, and the precision becomes 100%, 20 out of 20 total fish and rocks collected. Precision and recall are often a trade-off. Depending on your use case, you may need to optimize for one or the other. Consider a classification model where Gmail separates emails into two categories, spam and not spam. If the goal is to catch as many potential spam emails as possible, Gmail may want to prioritize recall. In contrast, if the goal is to only catch the messages that were definitely spam without blocking other emails, Gmail may want to prioritize precision. In Vertex AI, the platform visualizes the precision and the recall curve so they can be adjusted based on the problem that needs solving. You'll get the opportunity to practice adjusting precision and recall in the AutoML lab. In addition to the confusion matrix and the metrics generated to measure model effectiveness, such as recall and precision, the other useful measurement is feature importance. In Vertex AI, feature importance is displayed through a bar chart to illustrate how each feature contributes to a prediction. The longer the bar, or the larger the numerical value associated with a feature, the more important it is. This information helps decide which features are included in a machine learning model to predict the goal. You'll observe the feature importance chart in the lab as well. Feature importance is just one example of Vertex AI's comprehensive machine learning functionality called Explainable AI. Explainable AI is a set of tools and frameworks to help understand and interpret predictions made by machine learning models.